Here's the solution to Day 2, Problem 1. Question A, identify the slope and y-intercept for the graph of this linear equation. So let's do part A first, and then in part B, we'll graph the equation using the slope and y-intercept that we figure out. So the first thing we're asked to find is the slope. Another word that means the same thing as slope is rate of change. How is the value of y changing every time the value of x changes by 1 unit? So we can find the rate of change by finding some values of y and x. So first, let's substitute 0 in place of x to discover what the value of y turns out to be. 0 subtract 3 is negative 3. And so we have found that when x is 0, y is negative 3. There it is, written as an ordered pair. Now let's change the value of x from a 0 to a 1 and see what will happen to the value of y. So y equals 1 subtract 3. 1 subtract 3 is negative 2. Written as an ordered pair, we just discovered that when x is 1, y is negative 2. Now, from these values, we can find the slope, also called rate of change. Let's look at how y changed when x changed. X changed from 0 to 1. X increased by 1 unit. And what happened to y when x increased by 1 unit? It changes from negative 3 to negative 2. Negative 2 is larger than negative 3. It has increased by 1 unit. So writing that as a rate, when y increased by 1 unit, the x increased by 1 unit. Changes in y on top, the change in the x on the bottom. So 1 over 1. Now that does simplify just to 1. So the slope of our diagonal line when we draw it is going to be 1. Thinking of that as a rate of change, every time y increases by 1, the x will increase by 1. Now we're also asked to find the y-intercept, so let's do that. Y-intercept is a dot on the y-axis, and any dot on the y-axis will have an x-coordinate of 0. And so we can find the y-intercept by putting in a 0 for x. We already did that. That was our first work step. We discovered that the y-intercept was negative 3. So our y-intercept was 0, negative 3. So here's y-intercept, and here was the slope. We can use those values to answer part B, graph the equation. Let's start with the y-intercept because the y-intercept is a dot. Slope is not a dot. Slope is a way you can find a dot, but it itself is not a dot. So let's start with the y-intercept, 0, negative 3. Here's the origin. On the y-axis, go to negative 3, put a dot. There's the y-intercept. Now we're going to use the slope of the line to find more dots. Here was the slope. Let's think about what this meant in terms of rate of change. Every time the y value increases by 1, the x value increases by 1. Let's start here. Let's increase the y value by 1. I went up 1. And increase the x value by 1. I went right 1. Here's another dot. We could do this again. Increase the y by 1 and increase the x by 1. Increase y by 1 and increase x by 1. And we could do this multiple times. But at some point, we've got enough information that we can draw a nice straight line through the dots. Now, Day 2, Problem 2. The table shows how much grain is stored in a farm's silo. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and the initial value. When we look at this table, we can see that the first column, the variable x, is keeping track of the number of months that grain has been in the silo. And the second column, the variable y, is keeping track of the amount of grain measured in tons. For instance, after 4 months, there are 300 tons of grain in the silo. After 5 months, there's 250 tons of grain in the silo. There's less grain in the silo. And as time goes by, there's less and less grain in the silo because it's being used up on the farm. Maybe it's being fed to the animals, maybe it's being sold, whatever. Okay? We're asked for the rate of change. How is the amount of grain changing every time the months change? And we can find this by looking at rows of the table. We can look at any rows we want to, but for example, we might look at the first and second row. From here to here, 1 month has gone by. The x value increases by 1. And in that 1 month, it has gone from 300 to 250 tons. It has decreased, so negative 50. And we can write these changes as a rate. So rate of change negative 50 tons in 1 month of time. Another way to write this is negative 50 tons per month. Now another thing we were asked to figure out is the initial value, meaning how much grain was in the silo initially to start with. That's like finding the answer for y when x is 0. But the table doesn't have a row where x is 0. It begins with a row where x is 4. We're going to need to work backwards in the table to find the amount of grain for 3 months, the amount of grain for 2 months, and so on backwards until we get to the 0th month. Okay, so let's start with the row of the table that we know. After 4 months, the amount is 300 tons. But how much grain was in the silo after 3 months? And to find this, we're going to work backwards. The rate of change that we noticed is every time the month increases by 1 unit, the amount of grain in the silo is decreasing by 50. So how much was there in the silo before the 300? There was 350 tons. And then when 1 month went by, it decreased by 50 and made 300 tons. Let's work backwards again. How much was in there after the second month? 400. How much was in there after 1 month? 450. And how about the 0th month? 500. And so the initial value is 500 tons. The farmer had 500 tons of grain in the silo to begin the year, and then every month that goes by, the amount of grain in there is decreasing by 50 tons.